Good morning, everybody. Welcome back. We are going to jump back on the Indian Larry tribute Panhead build today. That bike kind of got pushed to the side. The white Fat Boy rebuild that we just finished doing belongs to the same person, and so we decided to do that Fat Boy build as it was just a quickie in relation to what we're doing with the Panhead. So the Panhead build got mothballed for a minute, but we're going to jump back on it today. I believe my plan is to work on the left side foot control. I think that's where I left off. It's been quite a while since we worked on this bike, so I'm a little bit turned around on what exactly we were doing. But that's the plan. I'm going to kind of get back into that, get my mind wrapped around what we were doing there, and see about working on the left-hand foot control, which is going to be a foot clutch, pedal, peg mount, all that good stuff. So we're going to hop out there and see what we can figure out. So our original plan was to run floorboards on this bike, but after mocking these up, I really just did not like the way they looked. So we elected to ditch the floorboards in favor of something else. So I'll go ahead and get this off of here. So first thing we got to do is make up a little drawing so we can make our main mount on the plasma table here. So I probably have this dimension already in a drawing somewhere because we've done obviously tons of foot peg mounts, but it's easier to quickly sketch it out. Got our 3 holes. Looks like 1 3/8 on both hole spacing, so that's nice and easy. And then I want to bring the peg up a little bit, so I think we'll bring the peg, I think 2 inches up. And then I also want to bring it back, being that it's a foot clutch. I find you have much better leverage when you bring it. I'm going to bring it in kind of snug. I think we'll do 2 inches back too. We'll try that. All the pieces can be interchanged. Obviously we can remake this piece if we need to, if we don't like it, once we actually get it all situated and are able to measure. So we're going to use this clutch pedal, which is a WR clutch pedal. So it'll basically end up kind of here for our clutch action. We'll make up a custom rod, obviously a custom hand shifter. So, but first things first, we got to go to the computer and draw up our parts. All right, so here we are in our Maverick CNC. You can see here, this is our software. And we're going to draw up this little foot peg mount. So what I always like to do whenever I'm drawing stuff like this up, even if you're doing this just with paper and cardboard to hand cut it, I like to do the same thing, is make all your holes. So your holes have to be where they have to be. Ooh, man, we are way zoomed out here. We don't want to do this. Let me get rid of this. And we need to get way in because this is not going to be that big of a part. A little undersized because the plasma doesn't cut clean holes, so there'll be 3/8 holes, but we're going to make them 300. That'll give us our location, but give us room to clean them with a regular drill, so we have a nice clean hole. And we're going to take this one, and we need to move it up 1.375. we're going to do this one. We're going to go move it over. So we got to go 90 degrees, and then we're going to do 1.375 as well. So that's our main bolt hole layout here. And then, like we talked about, we're going to do our peg mounting hole. We're going to locate it off of this upper back hole, which is what I measured up outside. And we're going to go 2 inches up. And then we're going to go 2 inches back. So that's 270 degrees. And then we're going to go 2 inches there. And this one here we're going to get rid of because that was just a reference hole. We're going to move this over. And now we have all 4 of our holes located in space, and we can start to make our actual part, you know, for the shape we want. So my plan is to use a piece of 1.5 inch round aluminum to start as the pivot point and peg mount, which will go up here. So in order for this to look right, what I'm going to do is find the center of this, and I'm going to give myself 1.6, so that radius will be a little bit larger than the 1.5 inch. Once we get that piece made and we can bolt it on, we can sand those edges together perfectly for a nice super clean look. So that's why we go a little bit oversized. Again, anytime you're doing plasma cutting, you run into issues where the cuts are never perfect. They always have some little bit of taper. There's always kerf involved. So I like, when we're trying to make a really perfect finished part, go just a touch oversized, and then you can, you know, either sand it or machine it or whatever into the perfect fit you want. So we're going to go up here. We're going to do the same thing, but we're not going to go that big. We're just going to go with a 1 inch radius, which should be good enough for overall look on the frame. We're going to do a 1 inch radius here as well. Obviously, when we get outside of our cut envelope, I'll just grab everything and move it up. So now we have basically the outline of our pieces, and we're just going to start to look at filling it in. And this is really purely cosmetic. So I'm going to go here. I'm going to go here and just lay in a little radius. However, I think it kind of looks good. On this side, I'm going to go straight. So we'll just get a straight line to the tangent. Get another one to the tangent there. And what do I want to do here? Let's try from the tangent to the tangent, and then just a really slight radius. So now you can see it colored in because we have a complete border. We're going to get our trim tool now. We'll come cut out all the rest of these pieces that no longer are required. And then you can see here where you get kind of a little bit of a funky angle. So here we're going to use our fillet tool, and I'll use a huge fillet radius here, and it just kind of cleans up the look. And we'll run our tool, checks for any issues in the thing, and no issues found, so we're good there. I like to reposition this into sort of the most compact little corner you can. It just saves material when we cut. We're going to be cutting this out of some 3/8 aluminum. So just kind of tuck that into the corner as good as possible. And then we're going to save it on our flash drive to take it out to the table and cut. here, file, save as. What is this? Panhead, left hand, foot peg, mount. Alright, we got that saved. We're going to head on out to the table and make a part. Alright, so we're over at the plasma table. Got the program loaded. Going to go ahead and get this thing fired up and get our part cut out. Again, like we talked about as we were drawing, this is going to do all our rough cutting, and then we'll do the finishing work by hand. Once we got that part roughed out, quick trip over to the drill press. We'll open up all our plasma cut holes with a standard 3/8 twist drill. Get everything nice and clean and a lot easier to bolt on than trying to plasma cut the holes, which always end up a little bit tapered and with some slag on them. So now that we got the part all roughed out, we'll get it bolted onto the frame here and start looking at our mock-up. We're going to add an additional hole to this for the foot peg clevis, but I didn't know exactly where we would want that until we could get it held in place in relation to the brake pedal and all that different stuff. So right now we're just kind of eyeballing everything, seeing how the fit is going to be and figuring out our distances as far as our spacers and pivot point dimensions. So you can see here, just grab the ruler and just figure out how wide we want to make that pivot point from the mounting plate to actually where the brake pedal pivot will be. Once we got that determined, we jumped on over to the lathe, tucked up a piece of 1.5" 6061. We'll go ahead and face it off to get started, adding some Dykem layout fluid here. Once we get it faced off, we'll be able to do our layout. Our WR foot pedal has a pivot point that's about 1 inch thick. So we're going to do a 1-inch shoulder for that and an additional 1-inch space to move it away from the mounting point. So overall, we'll have about a 2-inch piece with 1-inch shoulder turned on it, and then the secondary shoulder will have a taper cut on it to taper down from the 1.5 inch down to the 1-inch radius of the brake pedal, just so everything looks nice and clean and looks like it was made to be together. So we're getting close to our nose dimension. We'll stop here and check our pivot point fitment. Just make an inside measurement and take a couple more additional real light cuts. So we were real super close here, and our part had a good bit of heat in it from machining, so I didn't want to take it out of our chuck and lose concentricity, so I went ahead and just shot it with some brake clean real quick to cool it down and get a better check. We were still just a tad tight, so dialed in another thousandth and made a quick pass there, and that gave us what we need. You can see here we got a nice slip fit now. Just a tight slip fit, but with enough room for some grease. And because we want that to bolt on, but without locking down with the bolt, went ahead and ran the shoulder a couple of times, took about 10 thousandths off of there. So we have a little bit of a nose protruding from the brake pedal. And once we make our cap, we'll have a nice friction fit with no extra slop. So quickly now, I just pulled up an online taper calculator. These are super handy. I just Google taper calculator and use the first one that comes up. Real simple thing. You enter your major diameter, your minor diameter, and the length of the taper you want, and it gives you your degrees needed for your compound in order to make that taper happen. So throw our dimensions in here. I believe it was 1.5 inches on the major, 1 inch on the minor, and our length of taper is 1 inch. So threw all that in there and it gave us 12.68 degrees. Pretty simple deal. This doesn't have to be incredibly accurate, so I just use the tick marks on the compound and line up. It's probably about 12, somewhere between 12.5 and 12 3/4. They're not real fine gradations, but we're not trying to match anything. It's just a decorative taper, so doing it this way works just fine. And you can see here, we're just backing the compound out. And I don't know, it took about maybe 10 or 15 quick passes with the compound um, to get down to our 1 inch dimension, just so that it lines up nicely with the brake pedal. Went ahead and straightened that back out, put our radius cutter in there, nice radius chamfer, center drill, and drill for a 3/8 tap. And that's what's going to give us our place for our end cap to bolt on and hold the brake pedal in place. So now we've got that part all finished machine. We're back over at the bike. Gonna get our nice our clutch pedal pivot point mounted up to our foot peg bracket. And once we have that, we're gonna look at lining up our foot peg in the location we want. Gonna mount our foot peg into our clevis, so it'll be a nice flip up foot peg, and it'll allow us to use any kind of foot peg. These are the ones we kind of picked out, but I'm not really sure if I love them or not, so they may end up changing. Time will tell on that, but just figuring out what we want to do here. I noticed that the foot peg was in a little bit tight,
So first thing we did is just give a little mark on our mounting plate. We're going to drill our hole. I'm going to pop this back off real quick, jump back over to the drill press. Nothing too exciting. Didn't move the camera for all that, but just drilled another 3/8 hole, which will allow us to mount our foot peg clevis. And we're back with our part with the hole drilled in it, so we're going to remount that. We're going to put our foot peg clevis in using a kind of a long bolt, so we have plenty of room to pull it in and out and figure out the width we need. Something else on these pre-made foot peg clevises, the shoulders cut down pretty small, and I just never liked the way it looks. So went ahead and put all this together, took a look at it, and figured out I wanted to make the foot peg come out about 3/4 of an inch further than what we had going on here. Also went ahead and figured out the dimensions of our clutch pedal cap. Went ahead and machined that up out of some 1-inch 6061. Made a countersunk for a nice flathead bolt. So got that installed, and then moved on to getting our foot peg spacer made up here. Here you can see the narrow back on the foot peg clevis I was talking about, and this is now it with our new machine spacer, moving it out 3/4 of an inch. And I just like the thicker look. I think it looks nicer. By doing this, we did have to remove one of the bolts holding the foot peg mounting plate on. No big deal there. I'll just go ahead and countersink that hole, use a flathead bolt. It's just the increased diameter of the foot peg clevis was causing a little interference there. So went ahead and got that snugged into position. And we're going to slide our foot peg in, put the pin in, and we'll have it all kind of mocked up. Still debating on what we're going to do for the actual clutch pedal, whether or not we'll use a cable or a linkage bar, but a little piece of throttle cable hanging around. So I went ahead and slid that through just to kind of hold the pedal in position so we can get a better look at what we were doing and figure out if that's what we want to go with or if we want to make any modifications before we do any more real heavy duty work with it. So here you see all the mock-up done. You can see the cable holding the pedal up. We got our nice flush mount cap. Got our spacer on our foot peg. And like an idiot, I did not get any of the audio from our closing. So anyway, there was some stuff I talked about in there. We'll rediscuss that in the upcoming video. For now, I appreciate you guys being here. Hope you enjoy checking out this foot peg build. And we hope to see you next time at Gatti's Garage.